Hi, good morning. First of all, go Warriors. If you're watching this video at home and you have no idea what's happening, just come to render next year. Okay. So my name is Benedek Gagyi. This is my Twitter handle. I posted the slides there, so if you prefer to follow along on your phone, you can just do that. So one thing to know about me is that I really love tea. And this has two main consequences. The first one is that I kind of try to compare everything to tea. And sometimes these comparisons are really, really forced. And the second thing is that it made me realize that new technology is exactly like tea. I know it sounds strange, but bear with me. You see, when you hear about a new technology at a conference or read a blog post or anything, the first thing you realize about it is how you can use it, how to get started with it. And it's the same for tea, because when you try a new tea, the first thing you notice is the taste. And that's your first point of contact. But as you get more into it, you start to wonder, okay, where did this tea come from? When was it picked? How was it processed? And as you get even more into it, you start to wonder and start to think about, okay, how does this tea make me feel? How do I feel right after drinking it? And it's the same for technology, because after going over the first steps, how can I use something? You start to wonder, okay, how will I feel after using it? How will this affect my code base, my architecture? How will my team be affected? How is the morale going to be affected? So today I'm going to talk about writing cross-platform applications using WebAssembly. And I'm going to focus a bit more on this second part. I'm going to try to go deeper and focus on, okay, how will this affect your team? How will this affect you? How will this affect your architecture? But obviously, we can't really do this topic without answering the question, what is WebAssembly? So Brandon Eich, the inventor of JavaScript, posted this definition on Twitter. Obviously, it's a joke, but I really like it because it shows how many ways there are to define what WebAssembly is. A slightly simple approach is by saying that WebAssembly is basically a binary format. And for you, as a developer, this means that you can write a piece of code in C, C++, or Rust. You can compile it, and then run it in the browser. Because WebAssembly is a binary format, this has many consequences from the performance point of view also. So some people are saying that WebAssembly is actually the next step in web performance. And this is perfectly true, because since it's a binary format, it's inherently compressed. It was designed to be small, so the load times will be better. Also, there's no interpretation step, so it will run immediately. And because there's no interpretation step, and because it's typed, it has a consistent performance, so there's no need for warm-up. A function will run just as fast for the first run as on the 100. Also, there's a possibility to do a manual memory management. CPU features are coming, so you can see that it will be quite a huge impact on web performance in general. Some people like to define stuff by saying what it's not. So let's see what is not true for WebAssembly. First, it's not a solo mission. It's backed by the four major browser vendors, so Google, Microsoft, Apple, and Mozilla. It's a joint venture, so it's not like a fading fashion or something. It's going to stay with us. It's like a really strong base. It has a really strong base behind it. Also, it's not the next Java applet. It doesn't run in a sandbox. It has the same rights as JavaScript. You can touch the DOM. You can do anything you can in JavaScript. So again, this is like pretty encouraging. But sadly, it's not ready yet. What you can use today is basically an MVP version. You can try it out. You can play with it. But it's going to get better and better in the following months and years. The last definition I'd like to share with you is actually my favorite. It was said by Lynn Clark. She said that WebAssembly is a way to run programming languages other than JavaScript on the web. And for me, that's really exciting, because lately we were trying to push JavaScript onto all the other platforms. Using React Native, Electron, NativeScript, all these technologies, you were writing code in JavaScript and running it on the other platforms. But because of what WebAssembly is, we can actually take a piece of code that was written for another platform and then run it in the web. And for me, that's really exciting. Sadly, I don't really have more time to go into more detail about WebAssembly, but if you're interested, here are a few links. You can follow these. There are some talks there, tutorials, documentations. It's really easy to get into. Just click on these and you'll find your way. Instead, what I'm going to do today is, like I said, tell you how you can build a cross-browser, cross-platform application leveraging WebAssembly. And I'm going to do that by telling our story, the Join Me story. Join Me is a screen sharing conferencing tool that was released in 2012 for Windows as a native desktop application. And it got successful pretty fast. So the versions for Mac, Android, and iOS followed quickly. And for the team, it was pretty easy to add these new platforms because they just extracted the part of the code that's common, wrote it in C++, and C++ can be run in all these platforms pretty easily, almost trivially. But when they realized that, OK, we need a web platform, it got tricky. OK, how do you run C++ code on the web? Well, actually, back even in 2014, there was a way to do this. And it's called mscripten. Mscripten is a compiler that takes a C++ code and compiles it into JavaScript that can run on the web. Actually, it's ASM.js, but yeah, it's just JavaScript. You can imagine that this compiled code is not that beautiful. What mscripten does is basically black magic, but it works. Speaking of black magic, this is totally unrelated, but it's a fun fact. When the Harry Potter books were translated into Hungarian, Hogwarts was translated into Roxford. So I think the guy who did the translation knew something because yesterday I met a wizard named Harry, and he's actually doing a presentation right after me. So I'm on to you guys. Anyway, let's get back to WebAssembly. So what this meant was that we had all these platforms, and we had all these platform-specific front ends, but we could share a big piece of code, so which we only had to fix once when something broke, and so on and so forth. The team really creatively named this part of the code common, so I'm going to refer to it like that. You may ask, OK, what does this have to do with WebAssembly? Well, the thing is that mscripten is the official compiler for WebAssembly. So basically, if you have a setup like we did, where you're compiling C++ into JavaScript, by changing one single flag, you can make it compile into WebAssembly. So we've been doing this for 4 years, and that makes us kind of like the dream of recruiters, because we have 4 years of experience in a technology that's only 1 year old. Obviously, we have a ton of experience. I can't share in 20 minutes all of them. But I'm going to focus on 2 aspects. The first one is going to be the technological, the architectural things, and the second one is going to be the human side. So let's start with the technology. We had 3 questions that kept coming up over and over again, and I'm going to share the answers we think the answers we found were kind of working for us. So the first one, what should be shared? This may seem like obvious, but for us it wasn't. The business logic. The business logic is the only thing that you should share between these applications. First reason for this is because this way it's going to be language independent. Writing ifs and handling states in C++ and JavaScript is basically the same, so it's like no huge difference. And the second thing we observed was that you shouldn't ever share platform-specific code. It's just a really easy way to to create spaghetti code and to get into really nasty bugs. So please don't do that. Even if you're tempted, so even if you have like all these different front ends with different depths, and you're really tempted to share as much as possible, don't do that. An option we found, and something that worked for us, was creating an extra layer of shared code. So if there are 3 platforms that have a lot that's common, but the other 2 don't share it, just add another layer. We call that bacon because it's kind of in the middle, but obviously you can call it whatever you like. The second question we kept coming back to is, OK, how do you connect the layers? Well, again, this may seem obvious, but it was a really hard lesson for us that the contract, the API, the interface should be sacred. A really small change there can have huge effects. You have a lot of different platforms, and they behave pretty differently. Network handling and all these things are different. So even something that you might think, OK, this won't cause any trouble, on the other end of the line, it can become a really huge problem. Also, a way to think about it is to think about it like a backend. So even though it's running on the front end and it's part of the application code, you can, on your mind, you can separate it into 2 layers. And the third question is, should we go with a monolithic or a microservice-oriented approach? Well, the thing is that when you compile it, at the end, it's going to be a monolith. It's going to be one file, even if it was made up of a few modules before. So I suggest that for you to use a monolithic approach. Obviously, you can try it if it makes sense for you, but for us, this worked a lot better. And one extra thing, again, this may be common sense, but a really good continuous integration is a must. You have a lot of different platforms, really different, really complicated ways to build a new version of a product. If you don't automate these tasks, it will be really hard and painful to just test a minor modification. So automate as early and as fast as you can. Okay, let's see the human side. The first thing or first topic would be developer experience. How do you feel when you're developing in this manner, in this architecture? Well, I could compare it to eating. I know it's strange, but when you're using React Native or Electron, you're basically forcing JavaScript on all the other platforms. That's like saying that from now on, you can only use a fork and a knife, whatever you eat. And yeah, you can eat everything with a fork and a knife, but they are not the best tools possible. Some foods are better eaten with chopsticks or by hand, or a spoon, I don't know. And it's the same, that you can do it, but it's not the best tool possible. And I think as engineers, our first responsibility is to use the best tool for a given task. And this way you can actually do that. You can write in the native platform-specific, you can use the native platform-specific tools and the languages that are provided by the vendors. Okay, that's like on a personal level. But what about the team? Organizing the team is pretty complicated, and what we saw here was that the organization, the way you make up the teams, has a huge effect on how people think about problems and how they approach them. Because basically you have 2 axes, the platforms on the horizontal axis, and on the vertical one, the front end and the back end of the application, and front end and the common code. I'm going to focus on the 2 extreme approaches. Obviously, in real life, you kind of go for something in the middle, you combine these things, but I think it's easier to understand if you just see what are the 2 ends of the spectrum. So the first end of the spectrum is to use a horizontal organization model. Basically, you say that you have a team whose only job is to develop this common code, and different teams for the different platforms' front ends. The other approach is, the other extreme is a vertical Spotify-like approach, where you have teams who can develop a new feature from top to bottom, but there's no one team whose only job is to develop this common code. So obviously you can combine these teams if it makes sense for you. The main idea is to have it vertically. So I'm going to go through 5 different points of view, and I'm going to tell you how the different organization model affects your life from that point of view. Obviously, this is not only true for a model where you have like WebAssembly and cross-platform. This can happen on one platform too if you have a really big shared code base that's used by many other teams. So the first point of view is the approach. How do people approach their work in these organization models? Well, in the horizontal one, they think about themselves as product teams. It's really easy to understand why, because you're working on, for example, the Windows front end. You see how the product looks like. You're the owner of the product. The interesting aspect of this is that the people who are developing the common code are going to think about this shared library as a product too. On the other hand, in the vertical organization model, people handle this shared part of the code more like an open source project. So most of the development is done through pull requests, and even if there's a person who's like the maintainer, it gets tricky along the way. The second point of view is the point of view of performance. If you have a horizontal, really specialized team, they're going to be fast, because that's their area of expertise. They do that all day, all week. They're really good at it. The problem is that all the front-end teams will depend on your common team. So even if that common team is really, really fast, you have a lot of really good people working there, still queuing may happen, which is not that good. On the other hand, on the vertical one, the teams won't be as fast because they have to work with a lot of different technologies. They have a lot of focuses, but they are able to develop everything that they need, so they don't depend on another team. So actually the features that get into this common part of the code will be more democratic this way. The third approach is the side effects. How does your work affect the other teams? Well, in the horizontal organization, the common team may get ahead. They add new features, and the front-end teams have to adapt these. And it may happen, it did happen to us, that the common teams get so far ahead that it gets really hard to just catch up with them. On the other hand, if you have vertical teams, it's really hard to take into account the effect the code you're writing is going to have on all the other platforms. So it happened to us that we fixed something, and down the line, like 2 months later, we realized that that small fix caused a huge bug on another platform. So you really have to take care of this. The third, or the fourth point of view is going to be the point of view of the manager. Are there any managers here? Okay. By manager, I mean the person whose job is to make sure that people are motivated and love their job and are performing up to their standards. So in the horizontal model, everyone is going to be focused. And this is really good if you have people who like to specialize in something, because you're going to work with the same technology for a longer period. You have time to get really, really good at it, get really deep in it. But if you have a team where people are more like generalists, who like to touch different things, one day C++, the next day CSS, then I'd recommend to go with the vertical organization model, because there you have more diverse challenges. And the last point of view is going to be from the product owner. Product owners usually care about shipping the new features as fast as possible. And for them, the horizontal model is good because there's a clear ownership. If there's a problem, you know which team will be able to fix it. On the other hand, it's really hard to estimate when something is going to be ready if teams depend on each other. And from this point of view, the vertical organization model is better, because there, even if the team is slightly slower, they are able to develop everything they need, so they can estimate their work better. And up until now, I tried to be positive about these things, but here are the drawbacks of these models. So in case of the vertical organization model, there's no clear direction for the common code base. Everyone's just pulling in their way, and if these directions don't really align, that code base can get messy really fast. On the other hand, in the horizontal model, the front-end teams are always pressured to release a feature as fast as possible. And then if they depend on the common team, but the common team doesn't have time for their feature, they may solve it through a workaround. And you know how workarounds are. I just put this here for 2 weeks, then I'll remove it. Yeah, right. If you place one workaround there, the next time you will look at it, there will be 100. So again, this is a really easy way to ruin your code base. For us, the key takeaway from all these fiddling around with different organization models was that you have to adapt continuously. Different phases of product development necessitate different organization models, and you shouldn't be afraid to change up your team a little bit. Obviously, you don't have to go to the extreme, put everyone in different teams, but placing one person from one team to the other is totally normal, and I think you should build a culture where this is welcome and this is easy to do. Another thing that we observed was these diverse teams are really, really good. The first thing about them is that when you have a problem, a technical problem, it's not only JavaScript developers looking at it. There are people with Java, C++, Objective-C backgrounds, and all these different backgrounds breed a lot better solutions, because we're not thinking alike. The other cool thing about this is that the recruitment and the hiring is easier. Because if you want to scale and you have a React Native or Electron application, you tell your recruiter, okay, get me 5 JavaScript guys. And getting 5 really good JavaScript developers is hard, even in a big market. But if you tell them, okay, I need a C++ developer, an Objective-C developer, and a Java developer, it's easier because they are different. So from the recruiting point of view, for us, this architecture was a big help. Okay, but why should you use WebAssembly if you can just leverage everything I said by compiling C++ into JavaScript? Well, the two main aspects are performance, like I said before, but the second one is a bit more interesting and not that intuitive. It's accessibility. You see, if you're like me, a JavaScript developer, I'm scared of C++. Like, I still have nightmares from back at the university when I really had to use it. I know it's a powerful language, but the learning curve is really steep. So to have a language that's easier to learn, easier to understand, and it's friendlier for beginners, it's really important. And for example, Rust is such a language. So if you haven't tried it, Rust is a modern systems programming language, and it's a lot friendlier to get started with than C++. So give it a try. And talking about accessibility, if you want to try out WebAssembly but you don't really have that much time, there's a really good tool and NPM library called AssemblyScript. What this is basically a subset of TypeScript where you write a piece of code in JavaScript, annotate it with types, and then you can compile it directly into WebAssembly. So again, you're writing JavaScript and compiling it to WebAssembly. This is really cool because you can play around with it. You don't have to set up a really long build process. And you can learn pretty interesting things about WebAssembly. And like I said, it's really easy to get started with. And I'm going to show you how easy it is through a live demo. So I have a really simple function that calculates the Fibonacci number. As you can see, this is just plain JavaScript, but I added these types. So I32 is a 32-bit integer, basically. And what I have to the only thing I have to do with this is compile it. So there's an npm package called AssemblyScript, and you just run it by calling AssemblyScript, the name of the file, and the output. Enter. It's a really fast compilation, and then you can run it in the browser. The way you can run it in the browser is pretty straightforward. I mean, it will be pretty straightforward. Today, it's a bit tricky to run a WebAssembly file in the browser, but please don't remember this, because it's going to get a lot easier. Another thing I did here was create the same function in plain JavaScript, so we can compare the two. As you can see, the fib.webassembly file appeared here, so let's test it. I have a plain site here, so I'm going to use the console. I have a WebAssembly object, and on it a function called fib, and then I can actually call it. And just to make sure that it's giving me the right result, yeah, the two produce the same thing. But let's see what happens if I call the WebAssembly version with a bigger number. I'm not sure that's big enough. There's a difference. Why does this happen? Well, if we go back to our AssemblyScript code, you see that I used 32-bit integers. But as you know, JavaScript only uses doubles, 64-bit floats. So we had actually an overflow here. But it's pretty easy to fix. Let's just switch from I32 to F64. Yeah, recompile it. Refresh the page. And now they are giving the same results. So I basically demonstrated it to you that even if it looks like JavaScript, it's actually WebAssembly, a typed binary format. if you have the time and you're interested, go play around with it. It's really, really cool, really, really easy to get started with. And like, you can't really write a cross-platform application using this. But for example, if you have a web application that has a part that's really, really performance sensitive, you may try to write it in assembly script, then compile it into WebAssembly, and there are situations, it's not guaranteed, but in some situations, this may provide a huge performance boost. So try it if you want to. I like to close my talk with a quote again from Brendan Eich. He used to finish his talks by saying that you should always bet on JavaScript. But I think in the future, and he also thinks this, this will have to be extended to always bet on JavaScript and WebAssembly. Thank you for your attention.